Mr. M presents Area of Parallelograms. Hello everyone. In this video we're going to take a look at finding the area of different types of parallelograms. The type of parallelogram that we're probably the most used to is the one that we're looking at right now, a rectangle. It's the most common type of parallelogram that we see in our day-to-day life. And by this point, most of you guys should know that to find the area of this parallelogram, I need to multiply the length times the width. So our formula looks like this. L times W equals area. That's in square units. In this case, the length is 8 meters. Multiply that by 3 meters, which is the width, and that equals 24 meters. And of course, I have to keep in mind that it's meters squared, because it's area. Pretty straightforward, right? But a rectangle is not the only type of parallelogram that we're going to see. Let's take a look at how to solve with a different type of parallelogram. Now, I know we said we'd look at a different type of parallelogram, but for a second, let's just take a look at a rectangle again. Once again, we've got a rectangle in front of us with a length of 6 meters and a width of 2.5 meters. And 6 times 2.5 meters equals 15 meters squared. Now, remember I said we'd look at different shapes. Well, a parallelogram might look more like this. Move that over, move the height over so we can still see it. So we see it now has not necessarily 90-degree angles, but acute and obtuse angles, and it has that sort of slanted shape. Now, I want to show you one more time what I just did. Rectangle, and moving this piece over, attaching it on the other side. Now we have our different shape of parallelogram. I want you to ask yourself, did I actually take anything away from this rectangle or add anything to it? I took the one corner and I just moved it. I haven't added any area to my original rectangle, and I haven't subtracted any area to my original rectangle, which means the area has not actually changed. So let's look at the measurements that I used to help me figure this out. I still needed that original length, and I still needed that original height. The measurement that I don't need is this one right here, because it doesn't make any difference to the area of the rectangle or to the parallelogram. So once I change that shape, I'm just changing the shape of it. I'm not actually changing the area. So my measurement is still 6 meters times 2.5 meters for 15 meters squared. It's deceptive. A lot of students think that they need to pay attention to that line on a parallelogram, but as you can see, it doesn't actually do anything to help me find the area. I've got all the measurements I need if I just have my length and my height or width of my rectangle. Okay, so now you try one. Here's a parallelogram with 3 separate measurements. 2 of them you need, and 1 of them is kind of a decoy. Why don't you try to solve it yourself, give this a pause, and then come back and we'll take a look together and see how you did. Okay, so let's see what you chose to do. Because this section right here could easily fit here, almost like an extra piece of my rectangle, I need to visualize the length and the width. So I don't need this measurement here because it doesn't actually contribute to the outside shape of my rectangle or to my area of my rectangle. I need my length and my width. So as you can see, the length is 7 meters, the width is 3 meters, and when I multiply them together, I get 21 meters squared. So that's it. So when I have a parallelogram, basically what we've discovered is the formula for it is exactly the same as a rectangle. So if you can remember how to find the area of a rectangle, then you know how to find the area of a parallelogram. Just don't get tricked by that decoy measurement. All right, good luck, guys.